In a previous podcast, I looked at how to evaluate a logarithm. Actually, both of these examples were from that podcast. Now, the first question, again, that you ask yourself when trying to figure out what a log equals is what power would you put on the base, in this case 3, to get, and again in this case 27. And in the second one, what exponent would you put on 4 to get 13? And in the previous podcast, we talked about like this first example that hopefully your brain can just figure out that you would put an exponent of 3 on 3 to get 27. So the answer to this the log base 3 of 27 equals 3. But the second example, we couldn't figure out, 4 to what power equals 13? Don't know. Could make an estimate between 1 and 2, but what exactly is it? Not sure. So, again, this podcast is going to, kind of base itself that you've been introduced to something called the change of base formula. And I just popped that up here on the screen. And the change of base formula works in such a way that you can take a log of some base b, or a, of b, and change that to a ratio of two logs that have a different base. And that base would be c. And that could be any base. Now, since we'll be using a scientific calculator to help us with these problems, we will probably choose to use a base 10, because most scientific calculators work in base 10. Things to notice, just the structure of the formula. The base of both of these logs is changed to c, to the same base. And then the base that we used to have, a, shows up in the log in the denominator. And the b value is in the log of the numerator. So let's actually do this first one just to try this out. So what we'd say here, if we didn't know that the answer was 3 already, is that the log base 3 of 27 could be written as the ratio of two logs with any base that we choose. We're going to go ahead and choose 10, which again we don't need to write. So this would be the log of 27 divided by the log of 3. So what you'd do is you'd pull out your calculator, your scientific calculator, your graphing calculator. You would do this calculation, log of 27 divided by the log of 3, and you would get 3. So the log base 3 of 27 equals 3. Now, for the second one, same process. Log base 4 of 13 would be the ratio of two logs with a new base. You can choose whatever you want. We'll use log base 10 again so that we can use our calculator. So log of 13, log base 10 of 13 divided by the log of 4. So I'm going to pull out my calculator and I would type in the log of 13 divided by the log of 4, and we would get, and we'd have to round this off, but approximately, so I'll change this a little bit to approximately 1.850. So again, this answer is the exponent, approximately the exponent that you would put on 4 to get 13. Well, thanks for listening, and I hope that it helped.